Welcome Grilliverse. I am back with another new video. Okay, anyways, let's look at this next question. X and Y are hydrocarbons. The structural formulae are shown below. Right, the systematic name of X. So look at it very closely. This is not fucking tetramethyl methane, or whatever you were gonna think of it is. Remember the rule, count the longest C chain. So 1, 2, 3. This is a propane. So write that first, propane. Next step, count the groups. 1, 2, 2 methyls. So you just write dimethyl. Oh no, there's not enough space. Oh no, there's not enough room up here. Oh, there is. Okay, there you go. And now you're asking, why don't I have to add numbers like 2, 2? Well, there's only one combination of dimethylpropane because you can't put them here, because then it will just turn into a butane, which is a different story. Yeah, that's it. You can't put them here either, because then it just be pentane. Yeah. Anyways, Y suggests the difference between the burning characteristics of X and Y. Well, burning characteristics mean flame color or sootiness. And which one of these is more sooty? Well, if there's more H's, that means it actually burns less sooty. So that means because this is more saturated and this is unsaturated, this burns with a more sooty flame. So that's your answer. Y burns with a more sooty flame. Let's see if that's right. Where am I? Yeah, Y burns with sootier flame than X because the ratio is off, the C to H ratio. Because remember, the thing that causes the black soot is C. Carbon makes the soot. If there's less C in ratio with H, that means it's less sooty. Also, let's see if that was right. Dimethylpropane, that was right. Okay, cool. Besides burning, suggest a chemical test to distinguish between X and Y. Chemical test. Unsaturated alkene. Yeah, I mean, this is obvious. Br2 turns from brown to colorless in presence of Y. No, wait, no. Y turns Br2 colorless under standard conditions without UV light. Write down without UV light because X as an alkane can still undergo substitution while under UV. So let's look at this. Why can't I, okay, it's an image? Okay, whatever, just look at it. Y can turn acidified Cheminophore from purple to colorless, but X gives no observable change. It also accepts using Br2 in organic solvent or AQ. Remember that. Remember to write the state symbol. I forgot. Ha ha ha. Wait, why can draw a polymer? Draw the repeating unit of this polymer. How nice of them to give you all four bonds here. So yeah, that's quite easy. I'll write it for you. C double bond. Repeating unit. So write a giant line to connect between repeating units. Okay. This is a H, this is an H, this is a methyl bond, and this is, oh god, oh no, this is a dimethyl bond. And add a bracket, and N for repeating unit. There you go, there's your little thing. Little thingamajig, oh shit, little thingamajig. Oh. I mean, I think that's right. Yeah, no, that's definitely right. Okay, let's scroll down. Wait, that's it? That was 7? Oh, that is 7. Okay, cool. So, I guess we'll just do this one then. We'll do this one too. Why not? How nice. Using the following items only, design an experiment to electroplate nickel. Looking at this, I think you can guess what to do. Electroplate, which is like anodization, or what's it called? Galvanization, but with nickel on an iron rod. So in order for something to be electroplated on, you have to turn it from an ion to a metal. So therefore, we have to put a beaker down. I guess they said a beaker. Oh yeah, by the way, it says label diagram, so you no need to like write it down or anything. So just draw this. This is the solution you want, and there's only one solution here, so it's NiSO4AQ. Or if you don't want to be lazy, you can write the whole thing. I suggest that. So yeah, DC power supply, draw the DC power. If you're into physics, you know this. Now remember, if the orientation matters, this is the positive side, this is the negative side. You can write these symbols to make it less ambiguous. Ambiguous! Ambiguous! Okay. All the electrons flow to this side. So in order for nickel to turn into a metal, you need it to be on this side. Therefore, the iron rod goes here. Add a freaking label that says iron rod. My handwriting shit. Nickel strip should go here. That means that this is the anode. And since this is the anode, this should melt. This should like dissolve into the solution. Let's see if we're missing anything. DC power supply, nickel strip, iron rock, sulfur solution, wire speaker. There we go. Well, I mean, you don't really need to account for what goes on here, but just like keep in mind that this is the anode. State 1 function of nickel 2 sulfate electrolyte. You can write electrolyte or like a supplier of Ni ions, even though this also does it. But electrolyte's the safest bet because it's a solution. Formation of nickel. Yeah, I just did that. There you go. Simple. Just ion into this. Just add electrons. Let's look at the answer first. Nickel strip. Oh shit. Yup. Right. Solution. Act as an electrolyte. Yes. And also complete the circuit. Yes, this is important news. Complete the circuit is a key word. I forgot about that. You need to remember that. And also, yeah, I was right here as well. So cool. Provide action. I mean, technically that's what electrolyte does, but you know, whatever. Okay, cool. Yeah. Ni is a strong reducing agent than OH minus and SO4 2 minus. Nickel sulfate is green in color. Would there be any expected observable change in the solution in this experiment? I mean, this is pretty easy to answer, right? Actually, yeah. The explanation part I didn't quite get. I'll try to explain it, but you know, Ni is a metal, so it turns into an ion, so it keeps giving off Ni2+. But here, it gets absorbed back up to be plated. So there is no net change at all, so I'd say no. Repeat what I said there, but I really don't want to type it. I guess I'll type it. There you go. Give the backwards and forwards reaction here, and then say no net change, concentration. You have to remember concentration is the key word, and the conclusion. Let's see if that's right. Oh shit. Oh, yeah. Answer this. Oh my god, I forgot. Holy shit. While Ni2+ ions are consumed at the cathode, and Ni2+ ions are formed at the same rates. Same rates. I wrote this in my book. I didn't think to write it here. Oops. No change in concentration in the electrolyte. Yes, there you go. There you fucking go. And I think the last question is next. Yeah, E. State 1 purpose electron plate nickel on iron objects to prevent rusting. Alright, thanks for watching another video. Yay, is that it? Yep, enhanced corrosion resistance of iron and Give iron a more attractive. What? Really? Okay, well, I'm not sure about that, but preventing rusting or increased corrosion resisting power is definitely standard answer. So yeah, that's just write that.